Hello, everyone. I'm excited to present our work titled Multidimensional Machine Translation Evaluation, Model Evaluation and Resource for Korean at LREC-COLING 2024. This research has been conducted by Dojun Park, myself, and Sebastian Paro at the IMS University of Stuttgart. Before we dive into our topic, we want to draw your attention to the complexities of translation quality. Let's have a look at a simple German sentence and its translation on the slide. The original sentence, Die Katze jagte die Maus, correctly translates to the cat chased the mouse. However, the translation process can introduce various types of errors, which our research aims to address. First, consider the cat chased the ball. Here, the meaning of the original text is lost, which is an issue of accuracy. Next, the cat the mouse chased presents a grammatical error, impacting the fluency of the translation. Finally, the cat found itself in pursuit of the mouse. While accurate and grammatical, it changes the style. It is too formal compared to the original sentence. These examples demonstrate the different aspects of translation quality that needs to be considered for responsible and truthful translation evaluation. However, there is a limitation of current machine translation evaluation paradigm in showing these details of translation quality. To illustrate, let's consider the standard process used in MT evaluation, which involves three key inputs: the source text, which is the original text to be translated, the reference text, which serves as a standard translation used for comparison, and the target text, the translation produced by the machine to be evaluated. Following this setup, MT evaluation models like COMET or BOLT score then generate the single score that represents the overall quality of the translation. While these scores provide a general overview, they fall short in offering detailed insight into the specific qualities of the translation. In fact, there is a manual evaluation framework that addresses this shortcoming, MQM or multidimensional quality metrics. MQM provides a structured way to evaluate translation errors, categorizing them into major and minor errors, and it allows evaluators to identify and annotate specific issues in a translation. While we acknowledge the well-established role of NQM annotation, there remains a significant gap in computational studies, primarily due to the scarcity of NQM annotated corpora. Addressing these shortcomings, our research aims to contribute to the field in two significant ways. First, we have developed a 1,200 sentence MQM evaluation benchmark specifically for English to Korean translation, focusing on three key dimensions of accuracy, fluency, and style. Second, we approached MT evaluation as a multitask prediction problem, aiming to predict the three MQM scores simultaneously. This method not only provides detailed insight into each aspect of translation quality, but also enhances the overall evaluation process, yielding better results even when distilled to a single score evaluation. To begin with, let's explore how we constructed our English-Korean MT evaluation dataset, a key resource for our evaluation models. First, we selected two different types of parallel corpora, Global Voices, a former News Corpus, and TED Talks 2020, which are conversational presentation transcripts. From these, we randomly sampled 600 translation pairs, resulting in total of 1,200 sentences. Next, we paraphrase the English source text using GPT 3.5 Turbo, aiming to include somewhat flawed translations that exhibit a range of natural errors. Then, we use Google Translate to convert the paraphrased English sentences into Korean. Finally, we focused on three key error dimensions: accuracy, fluency, and style, and we annotated each sentence for major and minor errors. With our dataset in hand, we posed two foundational questions to ourselves. First, are the NQM scores that we have obtained reliable? Second, do the NQM scores provide us with additional information compared to single score metrics? To address the reliability of the scores, we employed cross-validation involving two independent annotators for a subset of 100 translation units using Candace-Tao correlation. Our results in the table indicate a strong correlation for both fluency and accuracy, indicating a reliable quality of the dataset. In contrast, the correlation for style is significantly lower at 0.34, suggesting that style is a more subjective aspect and is harder to annotate reliably. Regarding whether NQM scores provide additional information, we analyzed the correlation among the three NQM dimensions and the BLUE score. The findings show a moderate correlation of about 0.3 between accuracy and fluency, and that BLUE correlates to a similar extent with accuracy and fluency, but the correlation overall remains weak. This suggests that the NQM scores capture nuances potentially missed by single score metrics such as BLUE. Here is an example that illustrates the details of our NQM annotated dataset. Firstly, this is the Korean target sentences we generated by paraphrasing and translating the English source text. Based on the errors detected in the target sentences, the scores are calculated for each error dimension this way. Summing up these scores, we derive a total score representing the overall quality. For model training, we use a handful of state-of-the-art models as our baseline and compared how different configurations affect model performance. Among others, we focus on comparing MTE models utilizing three inputs of the source, reference, and target text to QE models that operate without a reference text. Now, let's have a look at the results of our model training. We demonstrate here the results of Rambert, which stood out among others, comparing various base models. Rambert in the MTE setup achieved the highest performance for accuracy, which is to be expected given the accuracy concerns the relationship between the input and output text. On the other hand, Rambert in the QE setup outperformed the counterpart for fluency and style, resulting in the highest performance with an overall score of 0.337. While for fluency, the results might be expected since it is primarily a target language property, it is surprising to see that it also outperformed in style. This suggests that the QE models may be learning to match the typical style of the corpus rather than an actual match between the styles of input and output. We brought our standout Lambert models into comparison with COMET-22 and COMET-QE, each recognized as state-of-the-art within the MTE and QE frameworks, respectively. Our analysis highlights that while both COMET-22 and COMET-QE are highly skewed toward accuracy, our multi-output regression models achieve a more balanced correlation across accuracy, fluency, and style. Interestingly, COMET-QE shows an enhanced correlation with human evaluated scores for style, suggesting it might better capture the nuances of style, functioning similarly to language models in distinguishing between styles. Furthermore, COMET-QE matches the performance of Lambert-QE in predicting overall translation quality, highlighting an interesting trade-off. Despite our model being trained on much smaller data set of only 1,000 Korean sentences compared to COMET-QE extensive 657,000, our language-specific training enables Lambert to compete effectively. Meanwhile, although COMET-QE has been trained on a vast dataset, it operates in a zero-shot setting for Korean, demonstrating robustness in language-agnostic training. As we conclude our presentation, let me highlight the key findings of our research. First of all, Lambert distinctively stood out among the models we tested, particularly excelling in the QE setup, where it demonstrated a notable edge over others. Secondly, our multitask learning approach has substantially enhanced the interpretability of translation evaluation, offering a significant advancement beyond the limitation of traditional single-score metrics. Lastly, our methodology has proven to be well-balanced across different aspects of translation quality, achieving results comparable to COMET metrics in terms of overall quality scores. Reflecting on our findings, it is also important to acknowledge some limitations that suggest avenues for further research. Firstly, our study primarily focused on the English-Korean language pair, which may limit the generalizability of our results to other language pairs. Secondly, our method employs a simple average to weigh different NQM dimensions for calculating the overall quality score. While we adopted a straightforward method for general purpose evaluation, it might be beneficial to reflect the relative importance of each dimension in specific context. Lastly, our current framework didn't incorporate cross-lingual methods such as transfer learning. This method could potentially allow leveraging existing NQM data from other language pairs to enhance the model performance. Thank you very much for your attention.